any solar solution, how much power do you need? Every solar sizing solution starts with the load. How much power do you need? If you don't answer that question, then you can't go forward. You can't build anything. This is not theoretical. It's not abstract. We build to specific need. How much power do you need? Okay? Now, how long do you need it? Right? Because again, if we're talking about a standalone system, there's no energy storage. We don't have to worry about how long you need power. But, I'm sorry, in a grid tie, one that's tied to the grid, you don't have to worry about how long. But if it's standalone, you have to calculate how long do you need that power. Again, if my solution is undersized and my freezer is going to need 2,400 watts, if I don't size that correctly, the freezer is going to go down. It's going to fail. It's not going to do what I expected it to do. Also, if I don't calculate the various areas of loss in my panel, in my battery, in my charge controller, my cables, my fuses, if I don't calculate the loss, the customer is going to say to me, I want a system that will carry my refrigerator. I'll build it, and because I haven't factored the loss, it will not do the job. It's going to fail. You might have done your install perfectly, but it's going to fail because you have not factored the loss. So again, in the case of solar, we build over. We never build right to our need. You must build over because you're going to lose. Okay? Finally, we can calculate the minimum battery amp hour capacity. Take the watt hours per day and multiply them by the number you decided upon in 3. So I gave you an example, and I said to build out the house, right? We had a refrigerator, we had a freezer, we had 3 light bulbs, and we had a specific time that they were going to be used. So now, in order to understand the battery requirements, how big of a battery are you going to need in order to maintain the house that we just built? Okay? So take the watt hours per day. What was the total watt hours? And multiply them by the number you decided on. Right? That's the total watts. The watt hours times the number you decided upon. So what is that? Your refrigerator takes 100 watts. You've got 24 watts of 24 hours in a day. That brought us to 2,400. That brought us to 2,400 watts. Okay? This should represent a 50% depth of discharge on your battery. Therefore, multiply by 2, and convert the kilowatt hour result into amp hours. So what we're talking about is how long will these batteries support your installation? How long can it last? Right? So we need to figure out the total amp hours. What do we need for batteries based on what you've just done? How many batteries, how many amp hours do you need to carry that house? Okay? Once we've determined what the amp hours are on the battery, so we've defined our load, how much we need. Now we define amp hours on the battery, how much storage do we need. After that, we're going to determine how many panels do we need in order to do this that you just built. Once we know all of those things, once you've sized it completely, then you build. You put it together. But the very first thing in any photovoltaic install is going to be sizing. You will spend your time sizing the system. If you don't size it correctly, your system will fail. It will not do what you wanted it to do. So, now, we've calculated, we've determined what the house looks like, how much power we need. I intentionally took it from the book. I didn't use this example. I used an example for you. So now, figure out the amp hours. How many amp hours are we going to need to control that house that we just built? How many amp hours? Your equations are on the bottom. Battery bank capacity. Read that and answer that question.